Well, good evening, everyone. It's 9:05 p.m. Eastern Standard Time, and my name is Nathaniel W2NAF, and I'm standing in for Dave Larson, KV0S, who is unable to make it this evening. But he does send his greetings to everybody. So this week, for the Tangerine SDR group, this past week I ate lots of turkey, and I bet a lot of other people did as well. It was quite nice, and I have a few. I finished up teaching classes at the University of Scranton. I'm almost done with my grading. I have a little bit more to do, wrap up this week, and we've been working on the AGU posters as well. I have a couple things that have come up this week. One is I started kicking around the idea for when we're going to have the Hamsci workshop. So we'd like to have it virtually this year again in 2021. And the dates that I'm looking at right now are March 19th and 20th. So it's Friday and Saturday, March 19th and 20th, 2021. So you can let me know if that works for you. Reason we picked that is it's in March, right around when we had it last year. So it's about a year from last year. It's also after the QSO Today Virtual Ham Expo, but it's also the weekend before CQ Worldwide World Prefix Single Sideband. So I think the only contest you're up against is the Russian DX contest. So that's when we would be competing against. But it seemed if my choices were going against Russian DX or CQ Worldwide World Prefix, I think that's the one to go. So March 19th and 20th. The other email I got was from a ham named J Silber, Whiskey Alpha 2, Uniform Alpha Romeo, and he writes that he's the public information coordinator for the Eastern Pennsylvania section of the ARRL, and he produces a TV series on the YouTube channel, EPA, ARRL video called What Hams Do. And so he says our first TV show included science experiment segments from two young people who participated in the virtual ham convention this year. That was K8HPS, and she recommended Hamsci to him. And so he was wondering if you could do a TV show segment for the program on Hamsci, the personal space weather station. And I thought that would be a good idea. So can let me know if that's amenable to you as well. I don't exactly know what it would be. It might focus on one part of it. Maybe it would focus on developing the Tangerine SDR. Maybe it would focus on working on the magnetometer. Maybe if you do a couple, but you could let me know what you think about that. All right, that's it for me. So good. Next on the list here, Dave Whitten, KD0EAG. Go ahead.
Hello, everybody. I've been working on, well, Thanksgiving, of course, but also I've got a magnetometer in the ground now. Not sure I have it optimally aligned, but at least it's out there in a hole underground, and I'm recording data from it in the indoors, and it's so far it seems to be going well. Have not it's the data is pretty the formatting for the data and all is kind of grubby, but I'm also at the same time I'm working on the code. The testing code. I have essentially forked that whole project, and I'm refactoring it, rebuilding it. So there'll be a separate GitHub for a cleaned up version that's hopefully more optimal for people to use in with for testing or for any other use they have more of the optimal settings that at least what seem to be at this point baked in, and a few options added and a lot, and hopefully a bunch of options removed that are kind of bogus that seemed like a good idea at the time. And generally just make the code, make it more user oriented. I won't say friendly, but because it's a command line interface program. But so that's what I've been up to. And also that plus when all's working nicely, I'm going to start setting up the rsync scheme between the pies or and the cloud-based Linode instance, so that we can have a sensible repository that at least we can capture what people are getting for the time being until something better comes along. And so that's what's keeping me busy here. Back to you, Nathaniel.
Thank you very much, Dave. That sounds very good. I've seen a lot of good progress on the magnetometer this week. Excellent. Over to, why don't we go next to Dave Lewis. Go ahead, Dave.
Are we on here?
Yep.
Yep. Okay. Good evening to all. I'm just reading your mail, as the saying goes. Interested in a number of the projects, but especially the magnetometer project. I see Jules is signed in here too, so I'm wondering if he has anything to report tonight. So I'll just let you go with it.
Thank you very much, David. And why don't we go to Jules, K2KGJ.
Okay, can folks hear me now?
Yep.
Yes.
Okay. On Thanksgiving, I must admit I was working on the magnetometers while my daughter and wife were preparing dinner, and then I joined them afterward. I now have, and congratulations first of all to Dave to get a working magnetometer in the ground. That's great. We've got at least 2 people recording now. I have Scotty's board, new board mounted in one of the housings. I forwarded something to the list, which included some photos. I don't know whether that was received or not, or whether it got through, but there are 3 photos to show how I configured that board, the existing board, and then mounted it in a 2.5 inch pipe. It is down 30 inches under the soil level, and I have just looked at the first 24-hour run on the 30th, which completed at 7 p.m. your local time today. I graphed that, and it looks again quite close to the Fredericksburg mag site data, which I look at every day. So far that's looking quite good. I have the second magnetometer, I should say there are 2 of them. This is the 2 mag setup that I had originally working, but one of the mags appeared, one of the RM3100s appeared to have a problem. So I pulled that, installed a known working device, and then reinstalled that unit in my woodlot about 300 feet out from the house. I am currently recording from that as well, and will continue to do so and compare both those 2 and the, yeah, there we go. That's the 2 magnetometer configuration that is in the woodlot currently. The other photos I sent and were to the list just yesterday show the configuration of Scotty's new board. I'll pass that on again if it didn't get through, but at any rate, that's the 2 mag unit, and it's in a tray, which is basically just a segment of a PVC pipe of a slightly smaller diameter that I actually cut down on a lathe to fit. Mounted some plastruck rails, and then mounted the boards against that. And as you can see, that's how it fits into the pipe. It's held in place with some foam, and it's quite secure. And then everything is sealed up and sealed with RTV silicone rubber. I don't use PVC glue because I like to take things apart again. So I'm using PVC not, I'm sorry, poly, uh, the RTV is what I meant. I'm using RTV sealant, which works quite well. And I use that around all fittings on the pipe. And then the unit that you see there is held within the pipe by a sponge foam pressure pad. Yeah, so we're collecting data now, and hopefully this time with the 2 magnetometer unit, I'll have some data to give to, yeah, and that's basically what they look like when mounted in the ground. And I hope I will have some data to give to Hyman on comparison of 2 RM3100s that are located within 6 inches of one another in the same physical environment. And that's about it. I have some suggestions relative to this new board in terms of easier mounting. If the remote board was supplied without the 40-pin header attached and without the either the RJ socket rotated by 90 degrees so it's in line, or without the RJ socket attached, it is very easy to solder in leads from an extension cable to those connectors, and the thing sits beautifully and firmly in a actually a 2-inch conduit. You can a 2-inch PVC. You can also put it into as small as a 1.5 inch, which makes a very nice mount, very simple to use, and secures the thing accurately in place for easy alignment. All the ones I've got in the ground right now are aligned within, on the y-axis, within 50 nanoteslas. That's about as close as I can get it because rotating by 1 degree changes it quite a bit. So they're both aligned north with the y-axis at essentially plus or minus 50 nanoteslas. That's pretty much it for here, from here for now.
Thank you very much, Jules. That's a great report. Those pictures you I was bringing up, they came to me and to Hyomin and Dave, I believe. And I didn't see the 3 newer photos that you.
Yeah, I have
talked
the other
about,
for
so,
John, and I have
yeah,
the
feel free
others. Yeah, I'll send those to you. And why don't you put them up then?
That sounds great. And you can feel free to send them to the main Tangerine SDR list as well.
Okay.
Great. Thank you so much, Jules. All right. Next, let's hear from John, NAOBJ.
Oh, perfect segue. I was going to ask Jules one question. When he puts the pipe into the ground below the frost line, it looks like the pipe extends all the way to the surface. So what are you doing to keep the heat differential and isolating the air on top from getting down into the pipe?
Good question. That's one of the reasons I use smaller pipes. With a lower volume of air, there's probably going to be less vertical circulation. I would also assume that at least for the winter, the temperatures above ground are going to be fairly cold. I don't expect a lot of convection currents. Typically, the lower part is going to be the colder part. So I'm just curious to see what's going to happen myself. One of the things I was concerned about with larger volumes of air are possible moisture accumulation, and so I put a few desiccant packets in there as well. But again, keeping that air volume smaller is one of the reasons I'm using smaller diameter pipes. I haven't measured anything. The only thing I see in the 2 mag setup is the temperatures of the 2 magnetometer board sensors, the 9808s, track very closely. Again, they're 6 inches apart, but I see essentially over a 24-hour period, less than half a degree C, in fact, even less than that, change in those temperatures.
Because I would expect below the frost line, you're going to be sitting, well, 65F, whatever that's about, 20C
Yeah.
or 20, something like that.
Yeah, I'm looking at 44. I'm looking at 44F below the frost line here.
Wow. Okay.
Yeah, that's typically what we see. Yeah, that's typically what we see locally.
Okay. I guess it's going to be different in Ohio.
Well, you do.
Okay.
What I was planning on doing for mine was burying the pipe and then covering the top of it with dirt, so just the wire came up through the frost line.
Yeah, that's not a bad idea. Or pile leaves around it, or some sort of insulation. Sure.
Or fill it with sand or something you could pull out later. But yeah. But
I typically use dry. I typically use dry mason sand once I put the pipe in place and position it. Then I'll take dry mason sand and trowel it in around it rather than putting earth back in.
Yeah, I like the way you use the 1.5 PVC as a insert for the 2-inch, the 2.5 inch. That looks perfect. But your sentiments about the connectoring is exactly what I was talking to Scotty about, where I'd like to have the RJ45 facing off the end of the board instead of off the side because it's causing a problem. I'm going to unsolder all the ones I've got. My question to Nathaniel, though, is for the ones that I've gotten, I'm supposed to distribute, what amount of extra work do you want me to do others above and beyond me just handing them the board? Should I make them a closing, cabling, all that kind of stuff, so it's a plug and play, or what do you expect from me?
I'm not sure exactly. Why don't we talk about that during the open discussion or on Thursday morning?
Okay, we can talk about that later. Other than Thanksgiving this week,
okay. Yeah. For now, we'll just try your list.
Okay. I was working on, this is Maxwell W3 LLA's FT817, now with the Larry Bodnar GPS DO connector on the back and his Raspberry Pi, and I've got that all working and calibrated, so that's going to be going out to Fort Collins, Colorado soon. My main question, again, related to what I just spoke about, is I don't think I'm going to hold up the shipment of his station for the magnetometer stuff because I don't have the connectors in to do the extension yet. I don't have any software running yet to do it, so I'm going to send it out and then send that out later because he can be collecting data while he's waiting for that. Because I'm sure he's getting a little anxious, and I don't blame him. Being a 9th grader, that's kind of hard stuff to wait for. But been working on that and a host of other things. But yeah, back to Ned.
That sounds great. And of course, Sean is from Case Western Reserve University, and also from Case Western Reserve University is Christina Collins, KD8OXT. And she's been in touch with Hackaday. And so I just put a link in the chat with a Hackaday article that was just posted about her up Eclipse gathering project. So HamSci is now mentioned on Hackaday. So good job, Christina. All right, next let's go over to Mike. Mike Neruda.
Thank you, Nathaniel. Yesterday I was able to get the Cat6 cable pulled in to the conduit, squeeze it in with the other cables, and got it in before the snow started falling. So back to you, Nathaniel.
Thank you, Mike. I saw on the list that you had a few questions about magnetometer sighting. I don't know if they got answered, but if not, maybe we can talk about them during the open discussion to help answer your questions.
Oh, thank you. That would be nice.
Great. All right. So next, how about Scotty, WA2DFI?
Okay, very good. Hello, everyone. Good evening, good afternoon, whatever. I guess good evening is pretty much everyone now. Of course, Thanksgiving took up the major part of the weekend, and some emails going back and forth between Tom and John and I on the clock module. Looks like John's making some pretty good progress on that, so that's a good thing. And see what else. Glad to hear about the magnetometers working okay. And yeah, any suggestions you have? I think we can, for now that we have 2 votes for no connectors, the 2 most expensive connectors to mount are the RJ45 and the 40 pin because they're hand mounted through hole parts. So we could certainly have a version that had neither of those mounted, which would only be usable in the remote site. But then of course you would have to do what Jules has done on all of his and hand wire the cable connections up. So we'd have to have kind of a, oh, thank you. You'd have to have a how-to article on how to do that, on how to, to wire the cable up so that it would work with the RJ45. Well, I guess Jules is using a pigtail, so however we want to do it, that looks like an excellent setup that Jules has there, the picture that I saw. So I'll look forward to seeing the instructions on how to do that so that everyone can put them in the small pipe like John likes to do. And
Also be interested in how do you do the second unit so I don't have to run two Cat5 cables. I presume you disable the buffer and then you change the addresses so they don't conflict and then tie them all back on one cable.
Yeah, and you could do that with Dave's board, but you can't do that with mine because I don't have jumperable. I only have two jumperable addresses, and actually you could do that, except if you jumpered one of them for local, it's a local remote type of thing. So if you jumpered one local and one remote, you could hook them up together, but then on the other end, the temperature sensor is going to interfere with the temperature sensor on the locally strapped remote end. So that's, if this looks like something that we want to be able to do, it's worthwhile adding another jumper to make a third address so that we can have two of them hooked together like Jules does. If that's
I don't think it's a requirement. It was just more they wanted two units out there just to compare data for consistency. So this is sort of a one-off kind of thing. So I don't think that's on the list.
Okay.
Right, yeah, you do once temperature sensor is fine.
Okay. Because I mean, the thing is that the temperature sensor soldered down. So if you removed it on the local board, then you could do this with two. But like you said, it's not a requirement. It's something that's kind of a custom that Jules has made to do some checking. It sounds like your results are good. So I guess we don't really have to address that particular change. And by the way, John, I have 5 boards made with connectors rotated where they come off the end. If you would like,
how much do I have to bribe you?
yeah, if you'd like to have those, you know, I mean, I put them together with sets, but I wanted to give everyone the same stuff to start with. But if that would help you, I still don't think it's going to fit in your 1.5-inch pipe because of the 40 pin and and the RJ45. But
Okay.
if you do like Jules did, then you could just take the connectors off. Although, I mean, you could, if you want to be brute force about it, you could just cut the 40 pin connector pins off. And never mind that. And the other one you'll have to unsolder, the RJ45.
The 40 pin with the way it's soldered in, I can fit it in the tube. It's just the RJ45. The only inconvenience with taking the RJ45 header off is that you have to solder the cable into it, which means you have to know what the length is to give it to the person. And that's where the problem is.
Right. Well, what Jules does is he uses a short pigtail that has a connector on the end that he screws into the pipe. And then you just have a 6-inch deal that goes up to the top of the pipe, the waterproof RJ45, and
okay,
on that. So that's one way to do it. But I prefer to not have to ask anyone to solder. But there's lots of people who are willing to do that. So
well, that's why I want to know what to do, because I'm willing to do the work. I just need to know what I need to do.
Yeah. So the question that I have for the people who have these is, if we were to turn the connector so that it was a vertical connector. So in other words, the PC board is here, and instead of coming off this way or coming off this way, we came off this way, went straight up. Would that fit in your pipe? Because you basically, we may have to move the connector more toward the center of the board so that it wouldn't hit the curvature of your pipe.
That wouldn't help me particularly.
I think it would. If you look at the height of there and you put that in the center, it'll fit fine.
Right, but if we rotated it so the cable came off the top, it still is not going to fit in that size pipe.
Oh, I see.
The cable has to fit in there too.
Yeah,
yeah,
right.
detail.
Yeah, it has to be in line, unfortunately.
It would have to be this connector straight out instead of vertical. See, that probably wouldn't work.
But in general, I mean, we're going to have to make a decision sooner or later with our instructions as which are we going to settle on? Are we going to settle on it coming off the side or off the end? Because if it comes off the end on a Raspberry Pi 4, it interferes with the connector unless you put a spacer in. So if we say, okay, on the local end, we put a spacer, on the far end, there's no Raspberry Pi anyway, so it doesn't matter.
Have you considered putting it on the other end? I know that would require moving a lot of footprints around.
Would require making a whole new redesign is what. So what's the advantage, Dave, of the other end? I mean, why?
Well, then you don't care so much about its exact height relative to the existing connectors on the Pi board. And
right, on the Pi end. Okay.
Yeah, on the Pi end, and at the remote end, all you care about is that it's in line, with the long axis of the board.
And if we were to move it to the center of the board, then it would still fit in John's 1.5-inch pipe, I think. If we were to move it centered in the But we still have the issue
facing
of 40 pin.
vertical.
Yeah.
Because yeah, the trouble with that is, there's got to be room for the cable.
Well, no,
you
no,
know,
we
if
wouldn't
you-
make it vertical. We'd make it come off
Oh.
the short end, but it
Oh,
would
I see.
put centered in the board so that the pipe could
Yeah.
come down.
So
and
that connector would be facing here.
it would be facing toward the camera. It would
Right.
come
Yeah.
off toward the camera, but it
Yeah.
would be in the center of the board instead of on one
Uh-huh.
side.
Yeah,
And you can see the the
that
40
would be very helpful.
of
Yeah.
any interference
So-
problems here.
John, if we did that, would that mean that we could leave the 40 pin connector on?
Well, one thing I also have to mention is that all my Raspberry Pi 4s are in cases. So this connector is 3/10 of an inch away from even touching the tops of the pins
Well,
in the cases.
I can't do anything about that other than give you a spacer.
Yeah, well, what I've been using is the one I was showing you. It's about a $7 connector that gives you 7/10 above the board, then it plugs straight in.
I'd rather give you 2 80-cent connectors than a $7 connector. But I think I could. You want me to send you a couple connectors and you could try them?
Actually, yeah, that would be helpful.
Okay.
Or the boards that have the
Well, the
vertical
problem
one.
with those boards is they're still not. I don't think they'll still fit in your pipe because the connector
Okay.
is rotated, but it's still at the edge.
Okay.
You can try it. You're welcome to try it, but I think you're going to end up with a 2-inch pipe. Otherwise, it's not going to fit.
I will make the boards that I have work. I'll just take the RJ45 connector off, solder something straight in, and it fits.
Okay.
I'll
And
make it work.
I'll send you some connectors so you can get the spacer to see if it'll fit with your case.
Okay, I'll try those. I did order some from DigiKey already, but if you want to see if they work for the general usage, yeah, send them.
Okay. Do you want a couple or one or two, Dave, also?
I'm fine with that. I don't have that. I have an immense selection of types, but
There's the case,
but-
and then you put that in, you can see that it doesn't even come close to hitting it. And of course, it covers up the fan.
But if you had another connector like what's on the magnetometer and stuck it on the Pi, would that be tall enough to?
Yes, it would. You just have to have gold pins.
Doesn't have gold pins. It has tin pins.
Yeah, tin won't work for signals. For after about 18 months, you're going to be cursing at yourself.
Well, why is it? There's no vibration. There's no moving.
It's called tin fretting, where you get tin oxide on it. It takes about a volt to punch through it, which is fine for 8. We get into that later, but we had a big issue with this at Keithley, and it was a major recall because they're trying to pass logic level signals to tin connections, and it doesn't work for very long.
I read those articles that you sent me, but it looks to me like you need some vibration and movement to cause that tin oxide to form. And if there's no vibration and you just push it on and leave it there, I don't see how you're going to have the problem.
Well,
It requires motion of the pin in the socket in order to build up that oxide layer. Anyway, that's what I read. We can
That is
talk
not
about.
what we found at Keithley, but we'll talk about that later.
Okay, because if that's an issue, then we need to use gold connectors on the main board too.
Anything with logic level signals going through it must be gold if you want it to last for more than 18 months.
Well, okay, we can talk about that later, but I have some disagreements, I think, but I'd like to see more references that would prove that, because definitely we don't want it to crap out after 18 months.
Yeah, well, that was the failure mode in my Heathkit most accurate clock, as they used tin connectors for the motherboard, and after 18 months you could see on the pins all the little black dots where the tin fretting happened and everything opened up.
Really, even with no vibration or
No vibration. Nope.
Yeah. Okay. Anyway, I think that's about all I've got. So back to you, Nathaniel.
I have something else.
Thank you, Scotty. Yeah, go ahead really quickly.
No, I just was going to say I have something else during open discussion relating to the magnetometer board.
Great.
Looking forward to it.
Okay, Gary, AF8A, go ahead. Gary says, hello all. I have no transmit audio video this evening, 7-3. Thank you very much for joining us, Gary, and we'll talk to you soon. All right, next, let's hear from James Wolford, KG4DSG.
Evening all, just listening in and back to the net.
Thank you very much, James. That's great. Dave McGaw, go ahead. N1HAC.
Good evening, everyone. Short week work-wise, but working on a lot of Dartmouth stuff, but also did try to bring the new magnetometers, which conveniently we could call magpies. Tried to get them running, but they're not responding. I think it was implied that they're a different address than the other ones, and whether they are or not, I didn't see any software that addresses them. Is that to be forthcoming, or did that only go to certain people?
Well, Dave,
Yeah.
if you look at what David sent in terms of his current run mag setup, if you make a modification before you do a make, if you make a modification to the edit to the device defs file, the address in there is currently, I believe, 20. You can modify that to 23, which is the address on the board Scotty sent. Then do your make, and you will find that it now addresses the magnetometer nicely. I
Okay.
don't know, Dave,
Well,
would you suggest something else?
Well, there is a command line option to set that also, just when you run the thing. I think
where-
it's -M, as I recall. Let me
If it-
look.
Yeah, and that's what I use to test the board.
Yeah,
So,
and I've been running it without any modifications, as far as I know.
Yeah, I wasn't sure. I didn't use that, Dave, because I hadn't tried it previously, and I wasn't certain whether that was a working
Yeah.
option or not. So I just took the quick workaround. I'll have to use that now in the future.
Yeah, that was an early one from pretty early days, and I think it works, except that there's the peculiarity about it is that at the present time I have a kind of a mix of decimal and hex values.
yeah,
And I think it needs a 35 instead of a 23 or something like that to make it work.
that's
It's
exactly right. Yes.
Yeah.
Is there documentation of this? I looked on the GitHub and I didn't see anything referring to the new mag board.
which GitHub, what's the GitHub address you're looking at?
I don't remember. It's on.
Because I
the
think there's
computer
the simple
downstairs.
one. There's an older simple one.
Well, there's only
That's-
one that I know about that
Well, have you
is
tried?
the one that
Have you
I
tried
downloaded.
help? Dash help, I think, is or dash P.
Dash H.
Dash 8. Okay. It
Yeah,
gives you a list of all the commands.
yeah. And
But you say there are two GitHubs.
well, I think there is. Let me put it in the. Let me put the important one. It's not entirely as well. It's prominent on the website as I think it should be. I'll put it in the chat and also mail it to you directly.
Okay, great.
I think I have it open here somewhere.
Yeah, the one I've been working from is the Witten D/RM3100-runmag.
Okay, that's the right one. You should be getting version 0.90, I think, or something, or 0.09, I guess, is the current version of the code. I'm actually forking this today. I haven't made it public yet of a newer version, but that's the right. Let me just put it up. That's my new one. Let me put the address in the chat so I'm certain everybody has the current one, but this will be superseded for most use by a one that just has less junk in it. Now back to.
Okay, well, if you could just send some instructions so I know.
Well, there's
what
if you scroll
what the
down,
hooks
there's a good bit of, but it isn't entirely up to date.
Yeah. I noticed that you had changed a definition file earlier today, but it wasn't.
It may well have just been a, one of those, yes, I pushed the defs file up there when I was making sure I had everything in sync, but
so the version 009 is what it should come up as?
yes, yeah, that's what you should get.
Okay. Yeah, and one last thing, I sent an email to the Hamsai that I've been watching WWV as the sunspot cycle's getting active again, and amazed that 25 megahertz is coming through. And I've been, I would encourage us to have 25 megahertz as well as the 20 and below for the WWV studies, because that's one of the magic bands. And it's been coming in S9 here in New Hampshire. I kind of wish they had a Hawaii version of that, but we're lucky enough to have the Fort Collins 25. They took it off for a while.
It'll just be getting better as the sunspots get better.
Yeah, but I'm surprised it's coming in as well as it is. Every day, the last week, basically, it's been S9 during the day.
Well,
and then the little note.
Matt Deutsch at WWV says the 25 is considered experimental.
Well, that's what it says it is, but it didn't used to be experimental, and I'm very grateful that they put it back on. I used to listen to it when I was young, and it was, any of us that are interested in propagation up in that area, it's extremely useful.
Well, they brought it up real slow because there was a Canadian broadcast at 25 megahertz that Matt was trying to make sure they were not interfering with, and he kept cranking the power up and kept corresponding with them to make sure once he got the full power, he wasn't screwing them up, and he wasn't. So that's what was going on.
Yep. And then the other note that I mentioned this morning, I was listening to WWV, WWVH, and the Chinese station all at the same time. I didn't realize that there was a Chinese until I heard this. First, I was hearing pings off time for this on the seconds. Turns out they transmit UT1 during a part of the hour, which is in sync with the Earth, doesn't use leap seconds. And then they do Morse code ID, which 29 and 59 after the hour, and that nailed it. When I heard the CWID, it was like, yep, that's China. So propagation's a lot of fun right now.
That's great. Let's thank you very much, David.
There you
continue with the list for now. Very exciting about WWV and propagation. Jay, WB8 SBI, go ahead.
Oh, good evening, everybody out there. Just as usual, dropping in to learn and keep up to date about this stuff. Found the discussion fascinating and something I didn't know about taking the sensors and burying them in the ground. And I'm still not clear about the reasons why that is being done. Obviously, it is. And there must be a very good reason for it. I just don't know what that very good reason is. So one of these days, hopefully somebody can explain that to me. I was thinking about, gee, is this something to acquire one of these sensors here? However, I'm wondering, because of the fact I have a power transformer in the backyard, a power company that takes it from 4K volts down to 220 for household distribution, is that essentially going to nullify my location? In other words, no matter what kind of sensor or how good or how fancy it is or how sophisticated, you've got this big bulk power transformer, 100 feet away, that's just going to wipe it out. That's just going to cancel out everything. So that's a question here, in addition to the normal power lines and stuff like that. Otherwise, radio-wise, just been playing FT8 here. I've noticed in the propagation a lot, and I mean a lot, of one and done. You'll hear the station South Africa, Japan, Australia. You'll hear them one CQ, and that's it. No more. You can sit there and call them for an hour. You're not. They're gone. They're just. You've been listening for an hour. You hear them one time, and that's it. And then you look at the other traffic on the band, and you hear I'm in Michigan, and you may hear them on some of the coasts, East Coast, the West Coast, other parts of the world that you hear other stations having a QSO with them. But here in Michigan or outside Detroit, where I am, nothing, zero. Very frustrating.
We do have some major meteor showers going on right now, which accounts for a lot of that one and done stuff.
Oh, this has been going on for weeks and months.
Well, it happens all the time.
Yeah, this is not a new phenomena. It's still just extremely frustrating, especially when I'm trying to get countries for DXCC, and it's just frustrating. You sit there for an hour, but okay, it is what it is. Thanksgiving, we don't do gobble here at this house. We did lamb chops with a good red wine, a very good red wine, and nice thick lamb chops. So that was Turkey Day here at this household with N8. The MYL is November 8 Fox Echo. So that's what we like. Otherwise, nothing new here in spectacular. In technical wise, even though there's nothing to do with amateur radio, I'm still very active in the Society of Automotive Engineers, Cybersecurity Committee, various ones, contributing to cybersecurity for electric vehicles, and also we're writing a cyber physical system security document for aviation, and that's an international community. So the chairman of that committee is in Germany, and one of our really big competitors is in Israel. Not competitors, contributors is in Israel, in addition to all over the U.S. So that's some of the that's keeping the embedded software stuff going. Otherwise, hope everybody is well, had a good, happy holiday, and is staying safe. And hopefully everybody will be vaccinated in time for the third weekend in May, when we may participate in the gathering. The gathering, which did not happen this year, but hopefully the third weekend in May, we can all have that good eyeball QSO. And if I have to tell you where, I could explain it, but you just wouldn't understand. Back to net control.
Thank you very much, Jay. That all sounds great. I think to answer one of your questions very quickly, the main reason they bury the sensor is because it's temperature sensitive. So by burying it, they're providing some temperature stability. And Jules is the one that that figured that out. And you can see also write you a question in the chat, which you can go ahead and answer in the chat for Jules. Let's see. And all right, so let's go over to, and regarding your siting, I think it would be good, your site would be a good test location for the magnetometer as well, because we need to test these things under a variety of different conditions, urban, rural. So even having a transformer in your backyard could make it a really good test site for us to see how it performs. So.
And it would also, in addition to having it's a pole mounted, bulk power, I think it's 50 kVA is what it's rated at. And there's overhead power lines, buried power lines, but also there's my household, my personal household 20 kW household backup power generator that I can run. It runs for 20 minutes a week for just normal self-test and everything. But I can turn that thing on as much as I want. There's no limit. It's natural gas fed from the gas company. So and it can power it, 20 kilowatts. There's nothing in my house. I can have the whole house going, all the appliances, HVAC, the stove, the washing machine, and the Heathkit SP220 full KW, a pair of 3-500Zs glowing in the dark. All going. This generator will go, yeah, all that. And what army? Bring it on. So it's a Cummins. The same people that make Cummins diesel engines. Like this one's natural gas, so it's Cummins. They know engines.
Excellent.
So yeah,
I think the
Thank
sensor
you.
has a 60 hertz rejection, so I don't think you're gonna have any problem with that.
okay.
Dave and Jules can chime in on that one, but I'm pretty sure it does.
Yeah, the question would be saturation, but it is filtered otherwise.
Okay, because it's enclosed in a chassis. It's enclosed, rather, it's a metal enclosure.
Yeah, if you're 50 feet away, there should be no problem at all.
Well, no, in the backyard, the only logistical problem would be burying the cable so the lawnmower doesn't get it.
Right.
That'd be the only logistical problem. But in terms of the generator or the bulk power transformer, we can put it right next to the thing or at the farthest away from those devices.
You might want to try that.
Yeah.
That feature with the lawnmower is called the auto rewind feature.
It's also called lawnmower fade.
Anyway, we can talk more about that offline here. So anyway, yeah, I'm really interested in that, and you just reminded me of one of the things, Nathaniel. You were talking about the other ham that is ARRLPIO from the East Coast. You remember I gave the presentation to the Scranton Radio Club on the AMSAT satellite. If anybody knows of any other club or organization that might be interested in seeing that video, please contact me. My email address is my call sign at ARRL at the league website, and be more than happy to link up with you and make it happen. I'm very flexible as to timing, so it doesn't matter if you're on the Pacific time zone or Alaskan time or Hawaiian time or or European time. We can do business. Okay, enough of that.
Thank you very much.
W2NAF WB at SBI.
Thank you so much, Jay. Appreciate it. All right, next we have Tom, N5EG.
Not much this week, so back to net.
Thank you very much. And how about Jonathan, KC3EEY?
Hi, everybody. I don't have too much to report. I finished up all of my semester work. And the good thing is I have finished up all of my academic work. So in a few weeks, I'll be graduating officially. Thank you again to Nathaniel for all your help and your assistance with that. I really appreciate it. I submitted all my work before Thanksgiving, and a childhood dream is now recognized. I'm now an electrical engineer, or at least in credential. But anyway, thanks, guys. I received the evaluation board for the TI-ADC. I was having some driver trouble with the XMOS processor. It seems like that normally a USB sound driver configures the processor, but in this case, the control software sets a couple registers that normally the driver would. So I was kind of having trouble getting it working right in Linux and FreeBSD under ALSA and OSS. But I'll keep working on that. I'm gonna have to get a benchtop power supply to drive it. That might have been some of my problem. I have a couple quick comments. When I was working on a thermocouple amplifier at work, I was prototyping one. The cold junction compensator required extreme temperature stability. Even the application engineer from Linear Technology said to absolutely use some way to keep air currents away from that, or else you're going to have your temperature measurement jumping all over. So what I found is McMaster-Carr sells this foam insulation. You could get it from anywhere, but we got it from McMaster-Carr. And the goal was to have the cold junction compensator and the thermocouple connectors thermally track. So what I did was I insulated around the connectors and the compensator IC, and that kept everything very stable. It's amazing. Just a little air current can make a big difference. So I would recommend. I haven't really looked yet, but to find some foam insulation and just pack the whole thing with foam insulation to make sure that there's no airflow at all, and that should keep the air currents at a minimum. Another quick thing, as for transformers set in the ground or on a pad for underground power, when a fellow who runs a VLF receiver, he was setting up his feed line and he needed to isolate. He needed to add audio isolation transformers. There were certain points in his yard where he actually had to break the connection and put in an audio isolation transformer. So instead of having one at the VLF receiver end and at the computer end, he actually had to put one in his yard and connect one of the leads to earth ground to keep this nasty triangle wave from getting into the feed line. So what I would recommend there is some form of electric field insulation, possibly around the pipe, and connected to an earth ground, and that might reduce some interference and might make the measurements cleaner. But that also might introduce some interference around the magnetometer. And the last thing, the sunspot cycle has been starting to creep up, and that also means more occurrence of whistlers. So it's a very good time to get the VLF receivers out, and we could get some good captures of whistlers. That's all I got. Back to the net.
Thank you very much, Jonathan, and congratulations again on completing your bachelor's in electrical engineering. That's awesome. And let's see.
Is he going to start working
Go ahead,
and
Jay.
take his professional engineer's exam?
Are you going to take your PE, Jonathan?
Yes, that is.
Yay!
Yeah.
Excellent.
Great. I think the last person
That would probably be me.
for this evening is Bill, AB.
Yeah, just remember the PE program is an apprenticeship program. Unless you can get a job in which you report to a PE, it'll just expire and won't do you any good. But anyway, okay, just been working down through my monster list of remaining features, bugs, and whatnot, which is there's 165 things on the list, but I've knocked it down to about 40 remaining items, I think, going through and tweaking things. And so I sent out a list of frequencies, and after thinking about it, I think what we're going to need to do is, hopefully somebody read that. I didn't get any comments back about it, but it's a tape. In fact, let me show it here. Let me show the screen.
I think Phil gave you comments, Phil.
Oh, did I get comments? Because I didn't see.
Yeah, Phil Erickson, Phil Erickson
Okay.
definitely sent you comments.
Okay, well, I'll go back and look at that. But the main thing is that typically when you specify frequencies for FT8 and Whisper, you're specifying the dial frequency. But if you're going to work with IQ data, you need to know the center frequency to set the SDR to. So probably what we'll do is do a computation, because we know the offset between the dial frequency and the center of the respective band. So if anybody else has any thoughts on that, please have a look at what I sent out on that and let me know, because if there's anything, any wrong assumptions I'm making, somebody needs to tell me, because I'm writing software that works, by the way, that's based on those frequencies I sent out. So that's about it from here.
Okay, thank you.
Yeah, Bill, I
very
had
much,
meant
Phil.
to
And I guess
feedback
we are
on
at 10 o'clock, so we had a lot of our.
Dave
I was
McGraw was
just gonna
saying
say we're
something.
at our 10 o'clock time, but we've had a lot of our. Yeah, we're at our 10 o'clock time, but we are at our what do you call it? But we've had a lot of general discussion as we went through the list. So I'd say we can just continue with general discussion now, and people can stand as long as they like. So yeah, Bill, if you want to talk about this with Dave, and
Yeah, Dave.
HAC.
Yeah,
I have some comments too.
the feedback I had on that is you're concerned about the amount of bandwidth having to store the whole, shall we say, audio bandwidth for just the Whisper. That you should be using the center frequency, and then I and Q, so you get plus and minus, and you only have to store 100 hertz bandwidth, because it's a 200 hertz bandwidth total for the Whisper band.
For Whisper, right? Yeah.
So whichever band, for FT8, it uses the whole audio bandwidth, so you're not really going to change that much. But still, you're still going to do better to tune to the center frequency, and then just rely on your I and Q to get the band that you're looking for.
That is the plan. That's what I realized after pondering this for quite some time. The only remaining concern I have was Scotty mentioned some I don't know, reservations about being able to provide I and Q with the center with an arbitrary center frequency. And so I'm hoping that that's not going to be an issue. But we did talk about the fact that the FPGA guys do have Pavel Demon's code, and somehow Pavel is accomplishing this. Not knowing anything about FPGA coding, I don't have a clue as how he's doing it, but hopefully we can do something like that.
You can have a problem at the exact center frequency due to offsets in the A to Ds. But the A to Ds nowadays, you don't have much of a anomaly there as far as I've seen.
Yeah, I don't think it has to be real precise because the frequencies are, they wander around a bit. I mean, it works perfectly well even if you don't have a stabilized receiver and transmitter. It handles this any inaccuracies very nicely.
Yeah.
So,
and it's
okay.
perhaps less important to have a radio set to a particular frequency and more important to know what that frequency is, right? Because as long as you know what the frequency is and you know what you're listening to, and then you can.
Well, if you're talking about FT8 and Whisper, the algorithms that the guys have developed for that are automatically deal with all of that. You just get in the neighborhood and it will automatically dig out the signal. I mean yeah.
Right.
So
I was going to have one other comment back on the thermal treating the pipes is, yeah, foam is one thing you can stuff it with, but fiberglass is a very good thing to stuff. It's very easy to take out when you want to, but it's designed to keep air from moving.
I don't think we have to stuff the whole pipe. I think if you just put a plug of foam or fiberglass, whatever,
right,
just above the location of the magnetometers, you've basically cut any convection currents.
Right, but that's what I do. I stuff fiberglass in there because it's easy to
good.
Make a plug out of it.
Yeah, it's easy to take out. It slides nicely.
Yep.
That was the other option when I was working on this, either fiberglass or foam. We did have a small piece of insulation that I was able to use fiberglass, and it also was just as effective. So
Granger makes a thing called handy foam, and it comes in a can. And you probably want to wrap your electronics in something so that if you have to take it apart, it hadn't gummed up your electronics. But you wrap the electronics in saran wrap, I guess, and then handy foam around it, and that's got such a high R value, it'll really hold temperature.
Just have beware that there's two types of that foam, and one of them is used for use in constricted spaces and one not. And if you use the wrong one, you probably break the pipe. Because I know if you use the wrong one insulating your door frames, it'll actually buckle the door frame in because it keeps expanding. So there's one that limits the expansion and one that just expands until it runs out. I learned the hard way.
I have a fair amount of
That'd be a good
gel.
thing to check. Also, by the way, we talked a little bit last week about or the week before, about the issue of trying to keep the Raspberry Pi components cool. With these spacers, it is possible to get the whatever board we're putting on, like it's a magnetometer baseboard, going on top of the Pi, and keep it high enough so that there's plenty of clearance for the fan to be in there. The only thing that I don't quite have a handle on is that fan has a couple of leads that generally they plug onto a couple of the pins to get ground in 5 volts. Well, now if you brought it out like this, where do you plug that? I mean, I'm sure there's a way to hack your way around that, but it's just
there's a very easy hack for that. On the Raspberry Pi 4 board, there's a protection diode right by the input connector, and you can grab +5 from the cathode and ground from the anode of the diode. You just solder the fan to that. That's what I've been doing. So you
solder the fan. Okay.
Are the leads long enough to bring up to the top and plug it on the top of the Pi?
They might be. They might be.
They're not quite in the case. So you wouldn't have enough room to come out of any hole and come back down again, because they're only about 1.5 inches long.
The other thing you could do is you could just solder the leads to the 5 volts and ground on the extension connector, and then plug it into the Pi.
Yeah, the kit that I got from Amazon, I think the leads are long enough to do that. But I'm going to test that. I'm going to Well, it's a solid top, so I got to cut it with a Dremel and then make a slot where this can come out. I'm going to work on that tomorrow, so I'll let you know.
So John, the protection diode you'd have to solder onto, right?
Yeah, it's a surface mount diode, and it's nice and big, and there's nothing around it. So it's real easy to solder the fan leads right onto that.
Yeah.
Which is what I've been doing to allow for the magnetometer board to be plugged on, because normally you plug it on pins 1 and 3.
Yeah.
I'm sorry, 2 and 4, which is +5 and ground.
Actually, interestingly enough, if you wanted to put a connector on your fan leads, there's a 5-volt connector on the pi hat. It's meant to be 5 volts in, but if you put the connector, if you solder it onto the pi hat board and put the mating connector on your fan, you could plug the fan right in there and it would be daisy chained on the 5 volts if your leads were long enough.
That's a good idea.
You
It
still have to
keeps
get them out.
wires inside the case with the way I'm doing it, so you don't have to worry about it. And they really don't have to come out of the case anyway. So
yeah.
Okay, that's all I had.
And your comment, I think you had a comment, Bill, about me not being able to give you exact frequencies. That was just, I was just trying to think of how I might optimize the code, because the plan is, 4 or 8, whatever frequencies you want. But all I'm saying is if I could make the frequencies multiples of each other, it means that I could vastly simplify the filter inside the FPGA, so I could get a lot more inside it before running out of space. That's all I was trying to say. So
okay,
if it might work that way, then we could do 2.499 and 4.998 and 10 or 9.996, and move it down just a little bit, because you're going to have 48 kilohertz anyway. So you're going to be able to encompass the frequencies that you need by just offset tuning your software and the other thing is, if you have a DC offset in your input, you're not going to want to tune to 0 anyway. You're going to want to tune to some other frequency other than the exact frequency of the LO, because any DC offset is going to be present at that frequency when you mix it. Okay, if that makes any sense to you. So like we have an A to D, and we have the antenna connected to it, and somehow with your preamp or whatever it is you have on there, you introduce 20 millivolts of offset of DC coming into the A to D. That DC will appear as a spike at 0 on the in your IQ data at 0 hertz offset. So you might want to tune the thing hertz off or something to get in. And I know Flex Radio did this. They got away from it. They offset it by like 11 kilohertz to get away from the 0 problem. And I think I'm not that much of an expert on A to Ds, but it seems like you get like 1/F noise when you approach 0. Is that so? You really don't want to be at 0. You want to be away from 0 some amount. So you don't want to tune it exactly to the frequency that you want to listen to.
Well, let me do this. I've got the stuff, all the values in a spreadsheet. Let me sit down and do some calculations and see if there are some places where we can get a twofer, like where one frequency could be used for to control 2 different sub-channels.
Yeah.
And that would be fun if we could do that. That'd be an efficiency.
Because of course, if you set it to 2.5, then you got 5, 10, 15, 20, all those are all multiples, right? But you don't.
Well, the whisper and FT8 frequencies, they're weird ones.
Oh yeah.
So,
and then like 14068.5 or something like that.
Yeah, I'm gonna, like it's for 40 meters is 7.074. A lot of them end up with something 0.74. So, and whisper is even weirder because but then remember, we're also working with in FT8 a 1500 hertz well, for both of them a 1500 hertz offset from dial frequency.
Right,
so,
but like if I haven't really operated FT8, but the idea is all you got to do is get the FT8 channel in the passband of the receiver, and then the software will do the tuning.
Yeah.
So if our passband is 3 kilohertz, or I don't know how wide it can be, and have the software still work.
3 kilohertz is what you want, so that you don't mix a lot of noise from outside the passband into it.
But if we were doing this in software, we could make it, instead of plus or minus 1.5, we could make it 0 to 3 or 3 to 6 or something like that. And it'd still be 3 kilohertz, but it wouldn't necessarily be centered at 0 if your frequency, your center frequency of your NCO in the FPGA of your IQ data was off a little.
Yeah, if it's off, well, when you say off a little, what do you mean by a little? I mean, if
Well,
it's off by 5 or 10 hertz, you're not
No.
going to see a problem. But
3
if you're off of,
kilohertz.
how
Say
much?
you're off by 5 kilohertz. Now you want to center your passband up at 5 kilohertz, not at 0.
Okay, Scott, we were working with canned decoder routines. Whether those will work with that, I don't know. We'll just have to test it.
They expect your center frequency to be within a few hertz of the
The
operating frequency.
I don't know how close it has to be. The way they have designed it to work is with a typical ham rig that you put on a dial frequency, you put it on an upper sideband, and then they deal with what comes in.
Right.
Typically about
3 kilohertz of slice. Yeah. Okay.
Yeah, a 3 kilohertz bandwidth.
Yeah.
So just out of curiosity, what would happen if you set the filter to 6 kilohertz? Would it not function as well because extra noise would get in and cause trouble? It's probably not designed to tune up at the edge.
I don't know. Well, hang on a second though. Remember, we're using a pretty low sampling rate. So FT8, for example, the decoder assumes that you're providing 4,000 samples per second.
Okay.
That's it. It depends on that. And the Whisper one assumes it's hard coded to assume 375 samples per second. So it's band. So all of that that high frequency stuff, outside the passband isn't going to be fed into it. I don't guess, or is it?
Yeah.
No.
Scotty reminds me that yes, there is the 1/f noise near 0 frequency that you have to be concerned about. That actually makes sense why we set our receivers to a lower frequency and then use upper sideband and bring the data in all on one side of the carrier frequency.
So like 0 to 3 hertz is not used then around the center. You throw that
right.
out.
Yeah, because 1/f noise is highly variable depending on the analog circuitry. You can get bipolar amplifiers that have a 1/f corner as low as like 10 hertz. But a lot of the FET amplifiers have a corner frequency up around 10 kilohertz. So the noise is rising very quickly down in the audio band. But what I'm thinking you might want to consider, if you haven't, is you might think of it as the digital equivalent of dual conversion, where you digitize it, with the 48 kilohertz or whatever, and then do a second conversion digitally, just for the, around the center frequency of this band of interest. That's why I was thinking of Whisper. You only need 200 hertz bandwidth. You don't need to pass more than that. That's that 375 hertz sample rate that you're talking about.
Well, that gives you less than 200 hertz of bandwidth, right? If you're 25 sample rate, you can't.
Well, you're actually, I'm curious about that 375. Actually, I think what that's doing is that's 375 doubled both sides of the center.
Plus or minus 375.
Plus or minus 375, right.
So 750.
Well, I have been told that if you're working with IQ samples, your sample rate is equal to your bandwidth. So if we're using IQ data and it's 375 sample rate, then the bandwidth is 375.
It's plus.
That's because you have the two streams, the I and the Q, give you that double the bandwidth, so to speak.
Right. So.
But yeah, so that's the thing to do is we would convert it, and this is all something you can do in the FPGA. That's what its job is you
I'm just trying
digitize it to the the basic rate, and then you downsample it again to the bandwidth that you really need.
And you'd have to filter it as part of your downsample.
Yeah, that's part of it.
But
Yeah.
then all of that downsampling, I mean, okay, so if we were to take the FPGA and we were to say, let's build a filter or a decimator that gives me streams out at 2.5, 5, 10, 15, 20, and 25, and say 40, I mean, pick a number, 24 kilohertz on either side of that, then each one of those streams could be fed into the same filter that would give you the small slices that you need for FT8. And as long as the FT8 frequency fell within that 24 kilohertz on either side of the center frequencies of 2.5, 5, 10, 15, and 20, you could pick out whichever one was the one that you wanted that gave you the frequency that you wanted.
Right.
Span that you wanted. I'm trying to optimize something I haven't designed yet, so it's kind of
yeah, sure.
But I'm thinking with the multi-rate filter articles that I've read, you could do a whole lot with equal slices, and you can get lots of equal slices for not much compute power if you could make use of that. So I'm trying to fit that into what you need so that we can get lots of slices out of the FPGA, because it is limited into how much logic we have. And I'm a little worried about getting you 8 totally independent slices, but maybe we can.
Well, I don't know how, well, somehow they managed to do it on the red Pitaya.
Well, and then maybe they did this double conversion thing or a multi-rate filter. I don't know. I haven't looked at the red Pitaya code, but that would be, it'd be something
Yeah.
to see how they did it.
Yeah, it's simply limited by the complexity of your FPGA, because that's fairly common. To bring it in at a high digitizing rate, we often did it at 66 megahertz. And then you can have several digital receivers all listening to that same converter.
And the red Pitaya samples at the same rate we do. And I believe their FPGA is smaller than ours.
Oh, yeah, it is.
So
much,
if he
much
can do
smaller.
it,
it's much smaller.
like they say, if he can do it, we can.
Anything they can do, we can do better.
Right.
Sounds good to me.
Neener.
We can do anything better than them. No, you can't. Yes, I can. No, you can't.
Besides, we're going to be like the orange Pitaya or whatever, the tangerine Pitaya.
Yeah, well, we've got all these fruit things. I ran across this incredible fruit, a fruit about this big, and it's not a watermelon. It's something called a jackfruit. Have you ever heard of that?
Yes,
I have heard.
Yes.
How about
You don't want to call your radio a jack radio, though. That's
a jackfruit. I cut this thing up, and unfortunately, they had one. I said, "What the heck is this? I'm going to take this home, cut it up." And the one that I had was really been sitting in the store too long, starting to turn brown inside, but it smelled good. So
what does this smell like?
Have you ever had mango?
Yeah.
It's kind of like a cross between mango and pineapple, maybe.
Oh, so like a really tart mango?
It's not tart. It's just, and it's got a little hint of banana thrown in. It's a tropical fruit, and then it's got these seeds that if you cook them right, they're like chestnuts. Pretty good sized seeds.
Really?
I mean, I'm sorry, getting off on a tangent, but anyway.
They're better than durians?
Yeah.
Well, durians smell bad, don't they?
That's what I hear.
Some say.
Jackfruit smells pretty good.
I like tangerines.
Those two.
Scotty?
I ate 2 of those for dinner tonight just to get ready for this conference, this telco.
Dave, did you have a question?
Well, I just wanted to mention that I have hooked up one of the boards that you sent to one of my boards using your board at I haven't tried all the permutations, but the version, with it is local and mine is remote. It worked fine with the right addresses.
I got the right pins then.
Yeah.
Have you tried it the other way around, using your board as local? And
I I haven't tried that. No, I wasn't really wanting to live dangerously. I just because I just wanted to try that, and
Well, I'm glad to
I
hear it
just thought,
worked, because I was worried that if I didn't get the pinouts right, because I remember on the very first version you had, I think the schematic had the data and the clock reversed on the translator, but you fixed it.
I'm sure I did that. I know I've done it on subsequent boards. It's easy to do.
Well, I
just
just
like,
want to make sure I picked the right schematic to copy, so I got the pins that
Mhm.
matched yours. But sounds like
Yeah,
I did.
yeah.
Thank goodness for that.
yeah, I've had some subsequent I have some subsequent designs that I made the same mistake again. I don't know, but it's
So
easy to do.
another thing that would be interesting to do, since there seems to be a propensity for people to want to solder the connector on, or the wire on, we could put a 1/10 inch header behind the RJ45, that if you wanted to put a connector on, then you could put a 1/10 inch center header, and you could wire a connector onto your RJ45 cable, your Cat5, and it wouldn't be waterproof or anything, but it would maybe be a little easier than soldering wires onto the board. I don't know.
If something like a 1/10 inch centers and have 8 pins,
Yeah.
single row.
Yeah.
Yeah, that would be great.
Like
I think-
this, only 10 pins.
Is that a 156 or is that a 100,000?
It's a 100,000 ramp. This is a KK connector from Molex.
Okay.
Everybody has these. And you can even put, since they're 10th inch centers and 0.025 square, you tons of manufacturers make headers that go right on them. And you can get, these happen to have individual pins. I don't know of any IDC connectors that will take a single row cable, but there are. And generally, they have the V-shaped sharp contacts, and I hate those because they cut through the wire and then they break off, and then you get no continuity. So
yeah, the IDCs.
What's
Right.
that, Dave?
This is a little board. It's actually out on OSH Park, so you can have them made. But there's one of the newer microprocessors from NXP or somebody. It's the Cortex M7.
M7. Okay, yeah, that makes sense.
Yeah, one of the ones that's pretty fast. And anyway, it's got a lot on the silicon, but it's got an Ethernet. But they didn't have room on the little board. It's those it's the tiny AT-Tiny 4.1 board, I believe it is, has place for a
like that.
header.
I
And
mean,
this is, yeah, it's actually, it's kind of like this, but it's actually 2 millimeter spacing for the header. And yeah, anyway, this is just the add-on board. Somewhere here I have the board that goes with it, the AT-Tiny thing. I've been trying to put them away, but that it's just the kind of way you can break out and use this, for a short distance. You can use a small header that you can buy pre-made.
And don't use anything as fast. I mean,
no,
right, our data rate's slow, so
I keep forgetting that this is not real Ethernet. It's this is 100K I2C and with differential, and so it works. It's pretty robust.
Yeah, the only problem is that we are so pressed for room on that.
Yeah.
But I kind of like your suggestion of putting the cable on the other end, except I know that it's going to mean starting over, so I'm not too enthusiastic about that. I'd almost rather just offer the board existing without the two connectors, and that's the remote board.
I would actually vote for that. I really think that almost anybody who's going to be interested in this has the technical ability or has a friend who does.
I'll second that.
To do this bit of soldering. Yeah, Jules.
Yeah, if you've got the wherewithal and the experience to build the pipe housing, and some of the craft work that requires, you're certainly good at soldering by that time.
And soldering on a single row header is pretty cake easy.
Yeah.
Yeah.
Well, even easier than soldering the wires onto the board.
Yeah. Whatever you wish to do, but just not populating those two headers and letting people do it themselves.
Oh,
I know I've bought an awful lot of microprocessors that way.
Well, and not populating is easy. I mean, that's,
Yeah.
especially through hole stuff, because that's all done as a separate step. So you can just snatch them away from them before they put those on, and you got what you need.
I think that has a lot to recommend it.
Agreed.
And actually, if we could manage, if we could even fit the header underneath the RJ45, because you're not going to use both of them. So if we leave the RJ45 off, then there's holes there for you to solder a header in, and you can go to town, and you'd be all set.
So what's the 10th inch header that is on there?
With
a dual row 10 pin?
Oh, that's PMOD. That's a PMOD interface. If you want to plug it in, if you want to populate those parts, you can plug it in and use it as a PMOD board. And that's kind of left over from the old days of when we were going to use this board as a PMOD extension before it morphed into a Raspberry Pi hat that now you don't need a PMOD connector. But old specs die hard, so it's on there.
Yeah, another thing you could easily drop. Well,
we could drop
if you
all those
wanted
connectors, right? We could drop all the quick connectors. We could drop the 5-volt. We could drop the PMOD. And then we'd have plenty of room for the connector.
If you just had 4 pins for SDA and SCL and 3.3 and ground that someone could do something with, but they can leave them to their own if they want to daisy chain these.
Yeah, I'll agree with that, Dave, because that's how I daisy chained the second RM3100 board that you had with, it was unpopulated, but I basically daisy chained it through the PMOD using the ground plus 3.3 and S clock and S data.
But it sounds like if you want to do that, we'd have to have another jumper to move the addresses yet again to the new address, because you need 3 addresses then, because you need 1 local and then you need 2 remote ones that are different. So, and the only jumper I have on there is a replacement for the Raspberry Pi. When you plug it on the Raspberry Pi, it automatically moves the addresses. But if you don't plug it on a Raspberry Pi, you can still move the addresses by putting that jumper JP1 on. That's a DNI on the board. It just pads. But unfortunately, it moves them to the same place as the local board. So that doesn't really do you any good. You need to move it someplace other than the local board so you can have 3 sets of addresses.
Well, even if you just had a cuttable trace or something, or
like your pads,
yeah, the solder pads that really take up very little space if they're one way or the other and don't cost a thing.
And you just jumper those with a blob of solder, right?
Yeah.
Access to the I2C bus side of the differential extender on the remote is handy for scoping and looking at possible problems on long cable runs and so on. It's really nice to be able to get to that I2C side on the remote.
Okay, on the cable side, you mean?
Yeah, but not the cable side, but on the end, the remote end of the cable, but the I2C level side on that rather than the differential.
Yeah, I've been scoping that on the magnetometer itself, but it'd be convenient if there
you can get to that on the Raspberry Pi header.
Yeah, but it'd be good to have explicit connectors or pins for that on the board.
Well, my philosophy is if there's a connector pin on the board that connects to something, I don't need 2 of them.
Right.
Well, if you got rid of,
but I guess what we're saying is if somebody wants to daisy chain something else to the I2C, you don't want to be soldering to the magnetometer.
No, but if you want a daisy chain on the I2C, plug onto the Raspberry Pi header. That's what it's for.
Well, if you're redesigning it, and personally, I would gladly trade even both the quick connectors and the Grove connector and the PMOD, that's quite a bit of board space.
Right.
you
Right.
know, for four 10th inch or pinholes that could be, you know, for where a header could be soldered on for purposes of testing and even extension if someone was
So,
so
so what would
inclined.
you'd put the I2C bus and 3 volts and ground on that header?
I think I'd bring in 5 volts and put an LDO on there, bring it down to 3.3. So you can accommodate loss and lines out to the remote head.
We have the 3.3 volt regular already on
that.
board. So we
Yeah,
can feed
Yeah,
some.
bring in 5 and 3.3. Couple of grounds probably in the I2C.
Well, there will be another revision, but you know, we're going to have to work on the specification for this because there's a lot of cool ideas that, and I, you know, I'm at this point, I think this is going to be used mostly as a Raspberry Pi and remote. So all those extra headers on there really don't make much sense anymore. The PMOD and those quick connects and all that. If you've got a header to plug it on the right on the Pi, what do you need those for? That was meant so you could hook it to the Pi with flying leads and not plug it in.
Now be aware that once I have the low cost station designed, I'm just giving you the RJ45 connector out to the remote head.
Right, you can put all the stuff that's on there.
I'm making my own interface.
Right, pick the same pin out, and then it'll work. And I was going to ask you that, Dave. Do you see do you have any interest in testing that D-Ready line coming from the remote?
I don't have any way to use it very much at this point. I have never made any provision for that in any of the code. And the way the code works, you know, it would mostly be for some other purpose that I can't picture right now. I mean, I love interrupt, you know, real solid interrupt based signaling, but it's kind of expensive in terms of the effort to make use of it. You know,
I was just curious if maybe you could even do a polling of it just to verify that it worked. Because I checked it using your code and some GPIO commands, but I didn't put it at the end of a 100-foot cable and let it.
Yeah,
yeah.
I can look at that at some point when I get the current list under control.
And I think at our data rate, it probably doesn't make a lot of sense to agonize over an interrupt very much.
I think there are other places, better places to put our effort for this. And I believe I'm using a small delay even after the software D-Ready comes, you know, to allow things to settle at Jules's suggestion. Because we don't want to be right. You know, we've got time on, you know, we're not trying to read it at 100 or 1,000 times a second.
I did test it and it worked. It was pretty amazing. I mean, I did it at keyboard speed, so it's not like it's. I didn't test the edges or anything, but I would generate the interrupt and then I would go read the pin and it was there, and then I would read it again and clear the interrupt and then it was not there, so you could verify that it went away when you cleared it properly.
Well, it's nice to know, you know, but you know, that's not something that I've had cause to prioritize. But
I'm not sure what that's
everybody
good for.
has.
I'm not sure what that's good for, because it seemed to me there's multiple uses for that. And I know that you can get a D-Ready when the measurement has been made, but I don't know if you can set limits, because it might be interesting to set you know, limits of some event that you're looking for that's, you know, out of the normal range of the magnetometer, and you could just set those limits and let it sit there. And if you got the D-Ready at some point, you could say, oh, an event happened here and we got some extraordinary reading that doesn't make sense, which means maybe Bill keyed down his 1500 watt transmitter and you read that instead of the magnetometer data.
I don't know, so much of the code early on when I was working on this that gave any hint of how this was working, is really so many of the uses, mostly the drone people have used SPI instead of I2C with it. And they might be, if they're reading it faster and reading faster, because an awful lot of them just plug straight into one of the popular drone, whatever it's called. I have one, a Pixhawk, I think, drone controller. It's a kind of a generic controller for drones, and but they all use SPI to talk to it. And I've got ones from, I got some of them from like Drotech and, some of these European ones, but there may be some reason, but I think it would be likelier that somebody would find a reason to add, if not another magnetometer daisy chain to this thing, then perhaps some other sensor that happened was, a low data rate sensor that they wanted to package with the magnetometer for some reason.
So they could
we already
on the 40-pin connector, if it's I2C.
Oh, they could if they can get at it, yeah. But it would be nice if there was an I2C coming off, just a pin header on the board.
The quick connectors are I2C.
Well, I know, but I was talking about if we just held on to that.
A normal
if we get
connector
quick connectors
instead of the quick connector.
Yeah. Yeah, I'm giving you an opportunity to sacrifice those.
Something you can see, like instead of those microscopic.
I didn't have as much trouble with those as it's just that one chip that makes me nuts. That PCA 9650.
That has a pad under it, right?
No, it doesn't.
Doesn't it? It's still hard to solder. Okay.
And I'm not that bad at soldering things.
But that's QFN, right? Only with the traces on the side of the part, no actual leads, right?
No, it's not. It's actually got leads, but
yeah,
it's
half a millimeter apart. That's the problem.
Yeah, they're 0.0. Yeah, they're half a millimeter, and they're and they just love to bridge.
Well, just let me tell you when I found those two pins, 2 and 3 reversed on that part. So I had to basically, the easy fix if they'd been 10th inch centers would be to lift the pads up, wire from there to the pad and from there to the pad. But at 0.5 millimeters, ain't no way that's happening. And so I actually got one to work, I gotta say. But I took it into my CM and I said, now you got to promise not to laugh at me because of the awful rework that I did, but I want you to take this crap off the board and do it the right way. And they did. And we ran wires from they lifted the pins and then they ran wires over to where the pads underneath went to another part because it was easier to hook to like the diode than it was to try to get to that pad underneath the pin. So we got wires that are maybe 1/4 inch long now instead of 50 thousandths.
Yeah.
But I did one just to verify that actually I did 2 because you have to have 2, right?
Yeah.
So I did 2 and I verified that it worked, and then I took them in and had our CM redo them. So those 5 boards, John, that I have, if you want one, they got wires on them, but they were done professionally. Like somebody could actually solder 50, half a millimeter. I can see them, but like I said, my iron tip's wider than 2 pins, so it's really hard to get solder on 1 pin. And then it bridges, and then you try to get solder wick in there, and then you melt the connector that's next to it, and then it's like.
Been there, done that.
But get this, you know how much it costs to put those 2 wires on the board?
I'm afraid to ask.
$30. $15 a wire.
Ooh.
That's why we respun the board, because I had 40. I could have built all of them and put rework on all of them. Would have cost more than respinning the board and building them right.
Wow.
So we had to do that.
On a later board, I did the same thing, but I fortunately had test points on those lines.
Oh, you're smart.
Yeah.
You put test
Eh,
points on.
And yeah, I've learned slowly. And I just cut the trace between the test point and the Raspberry Pi connector. And,
And the wire.
and
Yeah.
yeah,
Well, I tried actually scraping the solder mask off of a trace and soldering a wire to the trace.
yeah.
Easier to solder to a pin. Didn't work. So,
Well,
okay.
I'm
And I'm
gonna have to
not
go.
bad at soldering, but there's certain limits. Like Clint Eastwood says, a man has to know his limitations.
Well, I know mine, and I'm gonna probably have to say 73 here for now. But if everybody keeps an eye on the list, I will be posting things about the code revisions and try to keep up with my GitHub changes,
You
because
still have just the one GitHub that you posted on here, right? That's the one that I got your code off of.
that's the one you've been using. That's the one we've been using, but that will change. And it, uh, I have another one that's currently not made public, and I'm making my changes on that. I didn't want to get rid of this one because it has features that somebody may want someday.
Well, I like
But,
the code because it did everything I needed once I understood how it worked.
yeah, well, and I'm gonna try to do have more examples of using it. I'm trying, and what I really want is to know how the people who are currently testing it are um, are talking to it. You know, what command line they're using, because I know some people are doing it one way and some are doing it slightly other way. I don't want to stomp on options that people think are valuable. But
one question I had was, do you have to specify the address of the I2C port every time? It doesn't remember it if you use the command line, right?
No, there's a whole block of code in there to save a configuration file, but I never quite finished it.
Okay.
And it was getting amazingly complex just to do that one thing.
And I guess
And
every time I invoke the code, I invoke it brand new again, so it doesn't know what the last invocation did, right? So
no, it has no persistence of.
Okay.
Well, that brings me to the next point. I've got two pieces of code I want to release to the group. One is a Python script that sets up the entire directory structure for the personal space weather station, and then populates all of the metadata header files on it. So it's everything about the station. And I also going to have a piece of C code that I've been threatening Bill with, that he's been helping with. That's going to be the blockhead writer where you call this stuff up, it reads all the metadata and creates the metadata file at the beginning of your data storage for every day's data. My question to Nathaniel is where should I put that?
Where should you put the data?
No, the code.
The code?
Start using it.
You can put it to a GitHub, right?
Yeah, I have GitHub.
Okay. So where else should it go? That's what you're asking me?
Okay, it's in the documentation directory that I filled up for all that stuff. Just make another directory in there for the code.
That should be fine, yeah.
Okay, that's what I'll do.
I really want to see that metadata code.
Yes.
It's pretty important to me, I think.
Bill helped me out with it, and I just haven't had any traction on it. I keep getting interrupted with, setting up Maxwell Station and too many projects.
I think it's a work in progress. I mean, we're going to have to tweak as we learn more as we go forward, because I'm sure there's a half a dozen things we haven't thought of when we've been considering all that stuff.
That's why you make an iPhone 1 before you make an iPhone 10, right?
We'll get it. We'll get it.
But this gets you the basic start because it looks at all the basic files, where they're stored at, what the file name is, what the contents is, and all that stuff gets gathered and put into an organized fashion into every hit. I'm doing that now with the data collection for the WWE stuff. So that's been running now since July, early July. So it's been working pretty good.
This is going to automate things so that everybody has the same structure, right? That's the idea.
Well, that's what I want to do.
Yeah.
Everybody that's doing my code now has the same structure, but I want to present that to everybody so that we can all either modify it or agree to modify it. So we're all heading in the same direction.
Yeah.
It's probably going to be different for the Tangerine though, because we're using digital RF and we'll be using metadata inside the HDF5 database and stuff. So
right.
Yeah.
But the station ID, the node number, latitude, longitude, that kind of stuff, that's what this is all grabbing, which is pretty much generic for all the stations. You'll see it when it's there. But anyway, I will put it up there and then send a note out. But I was hoping to have that done a month ago, but 3 other projects bit me in the butt.
Hoping to have the data engine done in June too, but it's December now.
You didn't say what year.
So did you want me to send you a couple of those headers, or do you got some from DigiKey that are coming in?
I got a couple from DigiKey that are coming, so I think I should be all right. But thank you for offering.
Okay.
Julius, I was wondering about aluminum or copper tape around the pipe of the magnetometer to reduce electric field noise. Do you think that would cause interference with the magnetometer?
Let's see, if you cut a slit in the tape so that you don't have a completed, so that's basically a Faraday shield,
yeah,
and not a, then that would work.
Yeah, otherwise you have one shorted turn.
Yes.
Right. Yeah.
Because with my VLF loops, I would often shield them with metal tape, and then.
Do you think you get much electric field with it buried in the ground, though?
I haven't seen anything here, and I think with it buried, that basically any field is going to be very, very well. No, the conductivity of the ground is going to protect you against that for the most part.
Yeah, but being you're down 3 feet, it's going to be wet.
Yeah.
Okay.
Yeah.
Maybe if you're in desert, maybe if you're in desert sand, that's something else. But around here, no, the soil conductivity, we're medium ground conductivity according to the various maps I see.
So just some of that conductive PVC pipe.
Again, you don't want to. Yeah. Well, some graphite layer about it.
It's called galvanized steel, right?
Yeah, right.
Yeah, that would have a problem.
Yeah. Or copper, either one, because it'd be a shorter turnaround.
That's right. Oh, yeah.
Yeah.
Yep. Strangest things you run into.
Yeah, well, so at some point, I don't know when, Nathaniel, we're going to want to have production versions of the magnetometer available when people get done testing. Mm-hmm. So we'll gather up all of the pipe dreams and real dreams and suggestions and bad suggestions and good suggestions and try to come up with Rev E. It's at Rev D right now. I think it's really
shoot the engineer.
Yeah, that's the problem. Is we could make Rev Z if we kept going like this. And in fact, there was a guy at Motorola that was bragging about a guy that used to work at my company, who when he left our company. Actually, he left Motorola and came to work for us. But anyway, he's passed away now. But he had the only Motorola board that I know of that was at Rev A.
Wow.
And the guy who he worked for, the guy's board was at Rev AK. AK, that's like, I don't know, 20 some, they skipped the vowels, but there was like 20 some revisions of the guy's board. And he's telling me about this. And I'm going like, you should be more like Ralph, who has Rev A, instead of having like 20 revs of your board. So,
wow.
Anyway, it was just.
I think what we need to do is we need to, Jules and Dave are doing a really good job getting the ones that you've sent out so far into the ground and getting the code going. I think we need to get them to kind of get that wrapped up and start collecting data. And then we need to let the other people in this kind of cohort of prototype boards basically get theirs in the ground and start collecting data too, and
Yeah.
use the feedback from them to tell you what we really need to do to get it, what changes we really need to do before we put it into
Yeah,
production.
and we need to have the instructions on how to take the production model and put it in the ground. And
Right.
so we have to decide first what the production model is going to be, and then
Yes.
write the instructions for that. And then, because I can see it's going to get to the point where people are going to say, well, where can I get one? When I want to get on the bandwagon. So we have
And you
to,
know they're all going to want to use a piece of pipe to put it in the ground. So you basically have to have it go into some kind of pipe with 2 end caps. And that's the way it's going to, that's what production's going to need to support.
right. And that's
Yeah.
why we have, and when we pick the production changes, it'll support that configuration that we will write down
Right.
and say, here's the manual, build it like this, go buy this
Yeah.
PVC of this dimension and cut it to this dimension, buy the caps, and here's all the pieces that you need. And in
Yeah.
fact, yes, we could, at Tapper, we could make a kit that would include, because I mean, I can cut PVC. We make a kit that includes all the end caps and the PVC and the foam and everything that you need if we wanted to do that.
That would
Or
be great.
and that way, it would be way easier to get people to put their station together. That if
Yeah.
we just, no, you got to go to Home Depot and you got to go find the right size pipe and you got to get the caps that fit and you got to solder these wires on here and you got to do that and then and the other thing. Instead of saying, we'll take the kit from Tapper and here's the Heath kit instructions that say how to put it together, and then you got one.
Yes, I agree. That'd
Yeah.
be much better. Yeah.
Yeah.
But I definitely think we should let
Maybe we could get permission to call it the Heath kit.
Possible.
You call a ham sci kit.
Grease kit.
Ham kit. Oh wait.
Ham sci kit. It'll be the Hackaday people will love that. Let's see. So yeah, but
you need a lot more users when you make something easy.
I totally agree with that. I'm totally on board with that.
And I would rather spend an extra $20 and get the bag than have to go down to Home Depot and try to figure, oh wait, I got to buy 10 feet of pipe now. And what am I going to do with the other 8 feet? And then
how am I gonna cut it?
Yeah, and I got to cut it. And I'm going to hack it crooked, and then just give me the kit. Yeah.
Yep. I totally agree with that. I absolutely agree.
So
I think we just need to make sure we get this. We need to get the good feedback from Dave and Jules. Make sure that they have it working, and then similarly get some of these other prototype people to do some testing on it.
I was thinking
get a hole drilled in the ground here because we're supposed to get a foot of snow tonight.
Oh, we won't be there in time.
I'm jealous.
Yeah, we already got an inch and a half of rain today.
And we're supposed to get a foot of sunshine tomorrow.
So Scotty, then what's the timeline for Steam prototype data engines? And
yeah, I was afraid you're going to ask that. Yeah. Well, what I'm aiming for is to get the layout done by the end of the year and do the prototype build 1st of January.
Okay.
But what we're going to do is, and I think we're going to do this with the clock module too. We're talking about identifying the long lead parts like the FPGAs and buy them now.
Okay. So
that we're not going to have, because we know we're going to use that FPGA. We know we're going to use that Max, whatever that is, GPS. And the GPS has a 8-week lead, not the GPS, the oscillator has an 8-week lead time. So we need to buy them now because I want to be able to have clock modules in January and receivers in January also. So January is going to be busy.
So I think the way I would do it is I would kind of let Jules and Dave, kind of work they go off and work on the magnetometer, and then let the other people kind of iterate on the magnetometer. And while we're out beta testing, if you can really try to get that the data and
distracted by the magnetometer. Nathaniel froze.
And the actual Tangerine. Yeah, I froze. I'm still here.
Your video froze there.
It says my internet connection is unstable.
Oh, bummer.
I know, that's a bummer. Right. So I would say kind of let maybe if you put the magnetometer aside for a little while and let the beta testers do their beta testing thing,
So
and
what's
then
my
really,
direction? Do you want me to finishing up these kits like for David and for Christina?
yes, you absolutely do that.
Okay.
Yeah. So what I'm saying, Scotty, so Scotty,
You're freezing.
Tom, and John Ack. Scotty, hello.
There you go. Now you're back.
Okay. I don't know what. Maybe Dev might be downloading data off my connection because I have. It's possible because I have the I have my Edis USRP chirp sounder ionosonde receiver here. It's been storing data on the machine, and Dev has permission to log into my connection and download data whenever he needs to. So that could be what's happening to my connection.
So anyway,
but-
I think you said me and John and Tom should focus on getting the 3-board set going.
Yes, and the rest of us, we can focus on the magnetometer because we now have magnetometer boards out that we can play with. So John,
What do
Yeah.
you want to do with the remainder of them? Just hold on to them for now, or you what? Any idea of?
yeah, just hang on to them for now
Okay,
because
I have
just
8
hang on to them until. Yep, just hold on tight to those for the moment.
Okay.
So don't worry about those. John Gibbons, you are working on kitting up those grape stations for people, right?
Now,
And
should
you're
I
also
hold them up for the magnetometers or should that go separate?
if they're ready to go, I think they can go.
Yeah, they're not because I don't have any software written to talk to them yet. So, or collect data or
Okay.
whatever.
Yeah.
The
If you,
thing that we really
as
want.
I would say,
Sorry.
I would say as soon as you're ready to send people the grape stations, people should get grape stations.
Okay.
So, but
I'll put that
John,
in.
the magnetometers, when they plug onto the top of the grape, it's going to end up looking architecturally exactly like your Rev 2 grape with the stuff integrated, right? It's going to connect up to the same pins and everything.
That's my intent.
Okay, so the what I'm looking for just to see is is that going to work?
Okay.
Or
I should be able to do that relatively. Hopefully by the end of this week, I should be able to give you a thumbs up on that.
Okay. Doesn't have to be like 10 of them deployed, but just
Just one.
Is it going to run or not?
One works, we've got it.
Yeah. So okay, that'd be awesome.
Yeah.
And
Because
Scotty,
I think
we'll
we
talk
really need,
later
we really
about
need
the
to-
neons.
Sorry, pardon me?
Talk later about the neon tubes.
Oh, I still have to look for those because
I'll send you a picture of what I've got just to make sure they're the same. But that's another story. I don't want to drag this on.
They're Burroughs 4341s or something.
They're Burroughs something, yeah.
Yeah.
I'll send you a picture.
Okay.
And then yeah, because we really need to. I'd really like to see the prototype for the data engine and the whole Tangerine SDR soon.
I want to see it working before Christmas so people can play with it over Christmas.
Mm-hmm.
That's my intent.
Okay.
Well, he's talking about the tangerine, aren't you? Not the grape.
I think he's talking about the grapes.
I was actually talking about the tangerine, but
he's giving me a hard time, is what it is. To get my butt in gear and get going.
I had nothing to do with it.
Yeah, I know. He's right though. It's waited too long, and I got to get.
That's right.
Because I'd like to see the thing too.
To start cracking the whip.
Yeah, I know. Because I got a lot of FPGA work to do, and that's fun. This hardware stuff is dragging out, and not so much fun. And now that the clock module,
because we're coming up.
We're coming up on what?
We're coming up on the end of year 1 of the grant. So
yes,
because the grant, so January 1st is the end of year 1. So
and I never thought it would take this long, Nathaniel. I thought I would be well done with this before now. So
yeah, well, we still have time.
Still have time.
We can do it.
And we got the receiver done.
We can do it.
You do have the receiver
We
done,
have a receiver done.
and the clock module will probably follow right on the heels of the DE, or maybe he'll sneak it in before me. I don't know. It depends on how fast he is.
I'm looking forward to that.
Mm-hmm.
That's
Yes.
going to save my butt.
Mm-hmm.
It's morphed into something.
Did you guys
But cool.
Did you guys work out the issue with the pulse per second and the holdover?
Um,
I had some input on that.
The general feeling was if you're going to buy the cheap GPS, don't depend on the pulse per second very much because it's going to be crappy. So
that's going to be stopping the data acquisition if we don't have it.
Right, but the point that I want to make is that we're not going to try to solve problems that are solvable by buying the right GPS. So I think it's becoming a non-problem.
Yeah,
because we're just not going to use the cheap GPS. In fact, they're trying to convince me that we need two different board designs, and I'm resisting, but so far. But we'll see. Mainly because if we do have two different board designs, we could probably make the board smaller. And I'm looking at case options now because we're going to have a case. And what I want to do is I want to talk to this guy I know that does CNC machine cases, because that machine case that the RX888 came in is totally awesome. And I don't know if I could get the thing designed and then send it to China and have CNC aluminum powder coated parts come back for something reasonable in cost. But it looks like with our board stack, we could probably do a clamshell kind of CNC thing with some heatsink pedestals on it. And we might even get away with no fan. I don't know. Because if we do like what that, remember the case we talked about last week, that Neo, is that what it was? The Raspberry Pi case that has the pedestal inside, and you clamshell it together, it touches the top of the CPU and conducts the heat away. If we could do something like that, or even if we have to have a fan, you still have to have a case. You can't not have a case for the thing. So that's going to be like, the first question is going to be, where can I get one? The second question is, where's the case? So,
yeah, I agree. It definitely has to have a case.
And I don't think a plexiglass sandwich is really going to be adequate. I think we need a metal case.
Yeah,
and it's going to be about that, 4 inches square. It's not going to be inexpensive. But what do you guys think about a $99 case? Is that too expensive for a clamshell aluminum one? I don't. I'm just throwing a number out. If
that sounds kind of pricey to me.
Here's the
does it have to be metal? I mean, because sometimes you can get some pretty nice stuff made of the plastic injection molded, and you can make a prototype using a 3D printer.
Well, we could make the prototype, but the last experience I had with plexiglass versus aluminum was the aluminum ended up being cheaper, and it was much better. And since Tentec is out of business, I don't know where to go to get a bent metal box that you can put the thing in. And our stack is only going to be about that high. So, and the RX888 is, they've got a clamshell aluminum.
But what
sell the thing for $180? So,
what I would say, Scotty, is try to get the price and what a nice case would be. I think we should have a nice
like just as we have a cheap case that's injection molded or blow molded or something, and that's $20, and then we have the Cadillac case, which is the metal one that costs.
That's what Red Pitaya does. Red Pitaya has a cheap plastic case that they sell for like $10-15, and then they have the $60 aluminum case, which I have over there, which is substantial.
And the thing
somebody who's a real cheapskate, we just developed a 3D printer design and published a 3D printer design, because the case for my Red Pitaya is just something I had made in the UA 3D printer lab for nothing. Cost me nothing.
Yeah.
That's the ham. That's a ham radio solution for you.
Yeah.
Costs nothing.
Yeah.
But then, and we have a provision to put shield.
Yeah, I agree. I think what about shielding the RF boards?
We have provision on the RF board to put shields on it. So if we could do that, we might not even need a metal case at all. If we put the RF portion inside a metal box, then the digital portion, I mean, are we going to have to pass FCC? Probably not. We can wear a piece of test equipment. That's the way I look at it. I'm not selling Flex 6000s.
Yeah, this is
selling experimenters stuff.
Yeah, we're not going. This is not a or commercial sale. This is experimental.
But does the red pitaya pass FCC test or not?
I don't know.
How about CE tests if we're going to sell all over? I don't know.
I have no idea.
Underwriters Labs.
Pitaya there in the case to see
Do
CE mark on it. I sent mine to Dan, so I can't look at it. Dan said, by the way, I got a text from Dan. His computer blew up.
Oh no!
So he thinks it's the power supply, but he says he might not be on tonight. So he's still dealing with that.
I've got my red pitaya, but it's in the case, and
that's okay. Is that the cheap case or the fancy metal one?
That's the fancy metal one.
And is it CNC'd or is it bent metal or is it solid CNC'd out?
Does it look like an extrusion?
I think it's solid CNC'd out.
Yeah. And how do they do that for $60?
That's tough.
I don't know. Maybe we can.
They're getting them made in China for that?
Quantity? It's a beautiful case.
Is that made in Russia or in China?
I don't know that either.
Or maybe it's Russian made in China. I don't know. I think it's
Russian. See if it gets excited.
It's Eastern Bloc anyway, like Romania or Slovenia or someplace over there.
Yeah.
One of them places over there.
Well, they have a lot of very good manufacturing in Poland and Slovenia and that area. I mean, when I was working for Daimler, we started a factory over there because you've got a lot of manufacturing capacity available there.
One of the CMs we use
cost of living. So
the CM we use is in Hungary.
Yeah, that was the place I was thinking of. Hungary has really good.
Yeah. I read a story about a vinyl record factory in Hungary that was the old-timey factory, has been in business forever, and vinyl records started going way down, and they came within that much of going QRT, and then all of a sudden vinyl goes back, and now they're a booming business, and they stamp out lots of records and it's a factory that they stamp out lots of records for worldwide customers.
Wow.
It just happened to be because they were there when the boom started again, and they could ramp up faster than everyone else.
Right place at the right time.
Yeah.
Yeah.
So I can ask our Hungarian manufacturer whether they do any metal work. That might be. But I know a guy here that could do a prototype for us. That could take a chunk, hog it out, make it.
Ask the question if they can probably point you in the right direction.
Yeah.
It would be really nice to have a professional looking case available for this.
Yeah.
Even if not everybody has to buy one. Like, I think, again, if we go to the NSF and we say, look, here's the thing we made, and the program officer, the program officer holds it in their hand, and you can say, look, it does all of this and it feels good and it's
you have to put some lead weights in it so it'll feel even heavier.
And it's all put together nicely.
We could make it out of spent uranium.
Yeah, there you go.
Can it glow in the dark?
Yeah. No, but I think we could do some tests for Intel on soft errors,
Yeah, you have to wash his alpha particles.
That's right. Oh my.
But so with the RF shielding option for the board though, so then you think you wouldn't need a metal case?
Well, it's possible we wouldn't, because all the digital stuff would be outside, but the analog stuff would all be between the copper of the PC board and the metal shield. Because what we did is all around the outside of the RF board, outside of the RF portion of it, we put a track that's suitable for a custom shield that we can solder down over it.
Yeah.
And we have, and since it's on the back side of the board, which is really the front side of the RF board, we got as much vertical space as we need. So might work. I mean, we
did that at Keithley, and those metal shields can be made very cheaply.
Yeah, I mean, they're made out of like, you know, used Campbell cans or something. I mean, they're
Just so
really
happens.
El Cheapo metal.
This is a board I designed. This is the new Keithley electrometer. Let's see.
Is that a custom shield? Oh, yeah. So where did you go to get that made?
I'd have to ask the guy who did it, but that's the electrometer board. But yeah, there's a shield on top, and there's also one on the back here that pops off.
Huh.
We'll just take the back one like that, about that height, and we'll just solder it right down to the board.
And it's just a ring of metal that you solder with solder tabs, and then the things just snap on. That's real cheap to make.
Yeah. In fact, we don't have any tabs, but we have enough width that we can solder right to the strip. And you just solder it down to like every inch all the way around.
That's what this is done, about every inch.
And then if you have a bad part, that's your problem.
Yep.
Yeah.
So.
Been there, done that.
Yeah. Yeah.
Well, guys, I think I'm gonna have to call it an evening here.
Sounds good.
Sounds good.
Yeah, same here.
Same here.
I will be in
73.
touch.
Thanks, everyone.
We'll see you guys next week.
Take
Keep in
care.
touch.
Stay healthy.
7-3.
7-3.
Have a good night.
Thank you.
7-3,
Hey,
guys.
Scotty, did I sound a little more energetic tonight?
Yeah.
Yeah, I got a nap. Rachel had me take a nap before. She's like, you should go take a nap before your meeting tonight.
Oh man, I wish I had a nap before the meeting. Even though it's early here, it's still. But yeah, you were pretty awake tonight.
I know. Well, I had to be since Dave wasn't on.
Oh, that's right. You were running it, so. So you see, that could be the difference because.
Yeah, so I had to make sure I.
I know if I'm sitting here actually actively working on something, I do.
No, I also didn't. I also.
Go ahead.
Yeah. And the other thing is, I didn't. The semester, the teaching's over, so I didn't have any classes today. So I wasn't up until like. Wasn't up until.
Well, you're really breaking up now.
Until midnight the night before, and then up at 3 a.m. this morning. I wonder if Deb is.
So are you off till January now?
Until February. I think February 1st, the next semester.
Wow. So then you got 2 months to do R&D stuff and have fun.